Ganesh, Vaibhav, Tawhid, Pranavi, cricketer. There won't be any concept explanation in this video. Yes sir, you are right, Tawhid. So today we are basically going to discuss KCET PYQs from the chapters electric charges and fields, electrostatic potential and current electricity. 3 chapters combined. So 4 chapters are already live in our channel on Masterstroke theory. So if you want, you can go and check them out. But right now what we are going to do, we are going to solve some questions from these chapters, which are basically previous year questions, and we will realize that how many of them are we able to solve them without any help. So that is the major issue, because when you are solving questions, then only you will realize that how much preparation that you have, right? So 3 chapters together combined, we will I would like to complete this session in 1.5 hours. So if you are really that interested, you have to solve the questions along with me and tell me the answer. Okay, so first obviously we will go in the order. First few questions are from electric charges and fields, next we have electric potential and capacitance, and then we have current electricity. So 3 chapters one by one. I have not separated the question chapter wise, but I have given them in the order. So if you think that okay sir, you should have given the chapter wise order, I could have done that, but I have not done it for today's lecture. And obviously if you have any questions, any doubt, don't forget to mention in the comment section. Also one more important thing is that if you want to download the PDF of the lecture along with the questions and their solutions and all the previous Masterstroke lectures, then definitely you have to join the WhatsApp channel. And if you are someone who is watching our channel for the first time, just came here, then definitely subscribe is there, subscribe button, don't forget to subscribe so that we can bring more content to you. Right, so that is our target. So let's start. A metallic sphere of radius, initially I will go little slow. Hi Manjunath, how are you? A metallic sphere of radius capital R carrying a charge small q. So radius of capital R carrying a charge small q kept at a certain distance from one another. Okay, so here we have 2 spheres. Okay, one is small q radius capital R, and another one of sphere radius r by 4 and carrying a charge capital Q. Okay, so radius r by 4 carries a charge capital Q, and radius capital R carries a carries a charge small q. What is the electric flux at any point inside the metallic sphere of radius r due to the sphere of radius r by 4? So what is the electric flux due to this sphere on this sphere? Okay, so you have to find the electric flux due to the smaller sphere on the bigger sphere. Hi AK Kishore. Okay, AK Kishore, so it looks like Kishore. Okay, AK Kishore. Supriya is saying option A, Akki is saying option 1. Both are correct. Option 1, option A. Nowadays the questions in KCET do not come in ABCD format. So this is the latest format 1, 2, 3, 4, but some of the questions are there in both format ABCD as well as 1, 2, 3, 4. So here if you see that because this sphere is completely outside the first sphere, because this sphere is completely outside the sphere, no matter whatever charge on this sphere, the net effect of this sphere on the onto this sphere will be 0. The net effect will be 0. It does not matter what type of sphere it is, metallic sphere, non-metallic sphere, the answer will be 0. Now next question. You are given a dipole of charge plus small q and minus small q separated by a distance 2r. So if you see in the diagram, here we have 2 spheres, one dipole, 2 charges, minus q and plus q. Distance between them is capital 2r. A sphere of A of radius r passes through the center of the dipole as shown. Okay, so this sphere A, it passes through the center of the dipole, so that means the radius here is r. Okay, and another sphere B of radius 2r passes through the charge plus q. So this sphere passing through the charge plus q. Okay, then the electric flux through the sphere A. So what is the electric flux through sphere A? Okay, very silly question but solvable. Just to confuse you, some informations are given. Second, Manjunath is saying second is also A. Supriya Bangar, Manas, both are correct. Manas V Parmar. So he is saying option A. Second is also saying option A. Manjunath and Manas is saying option A. Supriya is saying option D. That is option 4. Let's see. Anyone else want to try? So here if you see that Gauss law states that electric flux depends only on the charge enclosed, no matter what is the configuration, it does not matter. We are only trying to find electric flux through this sphere. And what is the charge enclosed by this sphere? This sphere encloses only minus q charge. This sphere encloses only minus q charge. So flux must be equals to minus q by epsilon naught. Okay, it will not be 0. If you take the sphere B, then it would be 0. If you take the sphere B, it would be 0 because net charge enclosed by B is 0. But if you take the sphere A, net flux is not 0 because A is not including net 0 charge, it is including a minus q charge. So you have to be very, very careful. No matter if it is a dipole, it's an isolated charge, it does not matter. Gauss's law is only saying that the charge enclosed here is minus q. So correct answer is not A, not D, but C or option 3. Okay. Young Thor, you avoid gutka for better teeth. Young Thor, I do not eat or drink any gutka. This is by birth. Okay, some people have defect by birth. You may not have that. Okay, nowadays people use a lot of teeth correcting technology. Okay, so if you are promoting anti-tobacco, very good. I appreciate that. It is not because of any gutka or anything. It is because of by birth defect. Okay. I hope you understand that. Now let's move on, and I will appreciate if you try to answer the question instead of making any personal comments. So answer this question, Young Thar, this is for your question. Charges are uniformly spread on the surface of a conducting sphere. The electric field from the center of sphere to a point outside the sphere varies with the distance smaller from the center S. So what is the answer for this question? Charges are uniformly spread on the surface of a conducting sphere. So uniformly distributed on the surface of a conducting sphere, and the electric field from the center of the sphere, to a point outside the sphere. How does it vary? It's a conducting sphere, by the way. Remember, the radius is given by capital R. Okay, assume that it is given by capital R. And we are trying to find the electric field starting from the center towards at outside point, say at a distance smaller. So what will be the circuit? What will be the Sir, already in college BMSc first year. So okay. Manjunath Chavan, okay, now answer this question. Supriya is saying option A, Akishore is saying option 4, Young Thor is saying option 4. Okay, nice. So if you know that electric field inside a conducting sphere is 0. Okay, as you are moving on the sphere, electric field is 0. So up to this point, electric field is 0. So up to R, electric field is 0. So there will be no electric field line. Suddenly on the surface, it will go up and then it will decrease, fall like this. Okay, so this is the electric field on the surface of the sphere, and as you are going down, electric field will decrease depending upon 1 by r square. It is not 1 by r, it is 1 by r square. So correct graph will be option 4 or option D. Okay, now next question. Okay, before going to the next question, just want to remind you that ABHYAS KCET 2026 test series is already live and available for purchase, and here you will get 35 tests. Among them 4 tests are absolutely free. You can get them right now by registering yourself through your email and accessing the app through app or through our website only. You will get the access of 4 free tests. It will not come to your email directly, so make sure that once you register, you go back to the registration link and use our app or website, so to get the 4 free tests. 31 is paid. For that you have to pay some amount, and you will also get absolutely free of cost KCET chapter wise PYQs. Okay, KCET chapter wise PYQs for last 10 years. You will get that as a form of quiz. Okay, this is not simply solution and answer. You will get them as a form of quiz. So if you answer them as soon as once you submit the once after answering the questions, once you submit, it will show you which of the answers are wrong, which of the answers are correct, and why they are wrong. So it will also give you a practice. Also, the question paper is based on KCET pattern, and we have produced a rank from our last year. Prajwal, then Kiran, Deeksha, Sachin, Mohammad Sahil. You may have seen the interviews of Prajwal, Deeksha and Mohammad Sahil. They came and visited us last year. Okay, now with this thing, everything is priced only for 1499. It is already available, and already more than 1000 students have registered for ABHYAS, including our KC90 students. Now let's continue. Which of the following is a correct statement? This is a KCET 2025. So maybe Youngthar, when you answered this paper, you already know the answer for KCET 2025 questions at least. So let's see. Which of the following is a correct statement? Gauss's law is not applicable when charges are not symmetrically distributed over a closed surface. Gauss's law does not hold good for a charge situated outside the Gaussian surface. Gauss's law is true for any closed surface. Gauss's law is true for any open surface. Okay, so which of the following is a correct statement? So that means 3 of them are incorrect, only 1 is correct. So you have to identify which statement is correct. Sir, is NCERT enough for KCET? Yes, it is enough. If you study properly, thoroughly, in detail, then NCERT is enough. Okay, if you want to score right now, if you have time, then definitely you should study NCERT, right? But NCERT has a lot of extra content for KCET. So if you just want the summary of all the chapters, if you want to study only the excerpt of the main summary and gist of NCERT, then our Masterstroke series is the one that you should follow, where we are doing KCET and PU2 from NCERT only. We are not doing any content which is outside NCERT. All the contents are from NCERT, and basically in NCERT, if you like to study NCERT, very good. NCERT is more appropriate for biology and subjects like other subjects, biology and chemistry maybe, but for physics, the content, what I have felt that the book is first of all a little boring, and secondly, the lot of extra content is there which you may not require while studying for KCET. But if you can, obviously I do not discourage you. If you can, if you have time, definitely you should prepare from NCERT. But NCERT does not give you enough question practice. Question practice is limited in NCERT. That is one problem. So even if you read a line, you will not realize that line is important. Okay, you will just read it and you will think, okay, I have finished NCERT and I will score well. But when the question comes, you forget, oh, this question is, I do not remember it. Now let's see, question number 4. 4C. So many of you are saying option 3. Gauss's law is true for any closed surface. Yes, Gauss's law is true for any closed surface. Remember, it is not true for open surface. It is only true for closed surface. Next question. the total electric flux through a closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is, this question is from 2024. So dipole based questions are coming, and most questions are from Gauss's law based. So if you see that in 2025, out of the 4 questions that came, 3 are from Gauss's law based. Okay, so Gauss's law is one of the most important concept for your KCET preparation. So the total but don't only study Gauss's law, because from year to year the weightage of the topics also changes. Some year Gauss's law 3 questions came, next year maybe from another concept 2 to 3 questions will come. But 24 also this question is based on Gauss's law. The total electric flux through a closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is given. Epsilon naught equals to permittivity of free space. Option is 0, q by epsilon naught, 2q by epsilon naught, 8 pi r square q by epsilon naught. Rx Raghu. Sir, second question, in closed sphere B the charge is plus q, then it can be q by EO. Let's go back to the second question. So if you see that they are asking the electric flux through the sphere A. Sphere A means only this sphere and whatever inside this sphere. Anything outside the sphere does not matter. This is sphere A, this is sphere B. Sphere A contains only minus q charge. Plus q is for this sphere, for sphere A, it is only seeing whatever is inside, that is minus q. This plus q is outside. So if I ask you this question, okay, instead of giving 2 sphere, if I ask you 1 plus minus q over here, 1 plus q over here, what is the flux? Then you would have easily answered that, okay, minus q is inside, so minus q by epsilon naught. Okay, now if the same question, just they have changed the language, they have said, okay, there is a dipole, there are 2 spheres, so they are only to confuse you a little bit, to distract you a little bit, so that you you lose your focus that this is our sphere A, so anything else we do not consider. So if this is the sphere, we will only consider this sphere. Anything outside we will not consider at all. Okay, so sphere A has only minus q charge, so that's why it will be minus q by epsilon naught. You do not need to consider whatever is outside the sphere. Okay, plus q, minus q. This sphere is B. This sphere B has minus q as well as plus q. So for this sphere, flux will be 0. But for the inner sphere, flux is not 0. Okay, for inner sphere only minus q is there. So minus q by epsilon naught should be the answer. You should ignore anything which are outside the sphere, outside the closed surface basically. Not sphere, outside the closed surface. Clear? Okay. Question number 5. Option A, yes, correct answer, because now in this case what is the question? We have both plus and minus, both charges included inside the sphere, so net charge or q enclosed here is 0. So q enclosed 0 means flux should be q enclosed by epsilon naught, that is 0. Okay, so because does not matter what is it dipole or 2 separate charges, as long as the charge enclosed is 0, electric flux will also be 0. Now question number 6, a uniform electric field E equals to 3 into 10 to the power of 5 Newton per coulomb is acting along the positive y-axis. The electric flux, this is not electric flux, through a rectangle of area 10 centimeter into 30 centimeter whose plane is parallel to zx plane. So electric field is basically, suppose this is our x-axis, this is our y-axis, and x cross y, this is our z-axis. Okay, into the page. Now it says that electric field is along y-axis, so this is the electric field, and a plane which is parallel to xz plane, that means the plane is like this. Okay, now so this is parallel to xz plane, so what is the angle here? Angle is basically if you see that area vector or S vector and electric field vector both are in the same direction. So electric flux is given by E dot ds or Es cos theta. Here theta equals to 0 because when we take the direction of surface, we take in the same direction, perpendicular direction of the plane, and here they are in the same direction, so that means cos theta is 1. Okay, so the flux is only E into S. Now what is E? E is 3 into 10 to the power of 5, and S given here 10 centimeter into 10 centimeter. So S is 10 into 30 centimeter, and that means 10 into 10 to the power of minus 2 into 30 into 10 to the power of minus 2. So far this is the only problem where we have to use some sort of mathematics. So it will be 300 into 10 to the power of minus 4 or 3 into 10 to the power of minus 2. Now you have to multiply this with this. So 3 into 10 to the power of minus 2. So electric field will turns out to be 9 into 10 to the power of 3. Okay, so not electric field, electric flux. So it will be 9 into 10 to the power of 3 voltmeter. So option B is correct. Yes, 6B. Shaila Ahmed, Manjunath, Supriya, Aki, everyone is correct. Sir, in KCET, I think just they make questions big so that in fear we feel it's difficult, but in reality it is easy and moderate. Sir, we want all MCQs from question bank of all chapters, sir. Bunny, we have done MCQs of almost all the chapters. 4 or 5 chapters are left. You can check out. We have done a live series where we are discussing some of the important chapters. Important chapters are done. Some 1 or 2 chapters are left. If you want, we can do that as well, but you have to make sure that you are watching our channel regularly. It will come down soon. Okay, all MCQs almost, I remember 6 or 7 chapters are already done. I have done some chapters. Aditi ma'am, our chapter from our associate channel, she also came and helped me out for some duration. She also took 2 chapters in the live session, so you can check that out, right? PDFs are also available. You can download it from our WhatsApp channel. Next question number 7. You are partially correct, Kishore, because what happens is that they try to, if the question is easy, you will be able to answer them easily. Okay, so for easy question, they try to make the question little longer. There are few instances, there are few questions which are very difficult in KCET level, and you should not try and attempt them every year, from year to year. There is at least, last year the paper was easy. Apart from that, every year at least one question is very lengthy and very difficult. If you waste your time on those questions, then your entire exam will be gone. So you can skip that one particular question. Okay, every year I have seen in KCET paper, it comes from various chapters. One question will be very, very difficult. Okay, and it takes a lot of time to solve them, at least 5-6 minutes to solve, and even after that you may not be able to solve it. Okay, so read the question carefully. If you think that okay, this question I can solve, you should try. If you think that okay, this question maybe I will not try, you can skip it. Okay, but if the language of the question is simple, you should definitely try it, no matter how big the question is. And for calculation based question, anyway question will be simple, question will be short, because it's a calculation based question. They will not try to make it large. A body has a charge of -2 microcoulomb. The number of excess electron it has. So number of excess electron it has, that means Q is equal to Ne. So N equals to Q divided by E. Okay, so easy answer. 7C, students are saying 7C. Let's see. So N equals to minus 3.2 into 10 to the power of minus 6, right? Minus 3.2 microcoulomb, and electron is 1.6 into 10 to the power of minus 19. So it will be 2 into 10 to the power of minus plus 13. Okay, the negative sign is there for extra electron. So this is the electron, not proton, not lack of proton. It is the extra proton. Sorry, what I am saying, extra electron, not lack of electrons. Okay, so this is the extra electron. So excess electron is 2 into 10 to the power of 13. So question number 7, option is option C. Yes, Kishore, Bunny, Shaila, Supriya, Manjunath, Bunny, everyone is correct. Okay, so don't mention the answer 2-3 times. I will check once the answer is solved and marked in the board. I will definitely check if your answer was correct or not. Okay, don't worry. A point charge A of plus 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then easy question, very easy question. Okay, you don't need to do any mathematics, very simple, and obviously one concept involved. What is, I will tell you once you answer this question. Sir, I am PCM student. Please provide me just PCM ABHYAS test series. Please convey concern to the team. Kishore, the biology is just given as a free. You can skip biology. Okay, PCM is there. You can skip biology and you can attempt because some students have biology. So if we give two products, one with biology, one without biology, it takes a lot of difficulty in the back end. That's why biology is integrated. If you don't want to have biology, you can skip it. But I will definitely convey your suggestion in the team so that if it is possible that somehow we can give up only PCM series, that I will try and implement it. Okay, but it is slightly trickier for us right now, but I will definitely forward your suggestion, and if possible it will be updated and you will get the updation in our app only. Okay. Now a point charge A of plus 10 microcoulomb. Shaila is saying, is it option A? So if you see that this is a very easy question. One charge is here, one charge is here. Okay, now this one will apply some Coulomb force on this. Both of them are positive, so repulsion force. So this force they are saying F1, this force they are saying F2. Now from Newton's third law, if you take this force as action, this must be reaction. And what is the third law? It says each force has equal and opposite reaction. Equal and opposite. Okay, so when you are adding the vector sign, there will be a negative sign. Equal and opposite. Equal and opposite means they must be equal and they must be in the opposite direction. Okay, so it is not A but B. B is the answer. Okay, Newton's third law is the only way to answer this question. There is no other concept. You don't need to do any mathematics, even though they have given you the charges, they have given the distance. So as soon as you read, if you don't read the first question properly, two charges are there 1 meter apart, immediately you start, okay, K Q1 Q2 by R square. You started doing some calculation, but it is not required at all. So if you read the entire question, you realize, okay, these are only given to distract you. Only part is that this force is F1, the other force is F2. So from Newton's third law, they must be equal and opposite. You don't need to do any mathematical calculation. Okay, next, electric field at a distance small r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius r. The electric field at its center is E2. Then what is the relation? Yes, every action is equal and opposite reaction. Kishore, amount is not based on subjects. It is basically the effort that is being done, but I will convey your message. If you want to skip biology, that option should be given, and don't worry, we will convey your message as well if possible. Without biology, if the price can be reduced, that also I will convey. Okay, your message, I have heard it. I will try to convey it to our respective teams as well. Okay, now so what is the question? First of all, electric field due to a straight conductor at a distance is given by 1 by 4 pi epsilon naught 2 lambda upon r. Okay, 2 lambda upon r. Now Now the same wire, this is a very long wire, okay, it is a very long wire. Now the same wire is bent into a semicircle of radius small r. Now because it's a very long wire, okay, you can say that it even if you bend it, it will be almost a straight line, even if it's a semicircle of radius small r. Okay, it is very long wire, so we can take that electric field in the center will also be constant. You can calculate it, by the way, mathematically, okay, so 1 by 4 pi epsilon naught. But if you know the answer that even if you are taking a very long wire, you are bending it to a semicircle, the electric field remains unchanged. Electric field remains unchanged. In this particular case, it will be both will be same. So ninth question, so that's what I am saying, that if you know this fact that if a straight wire has an electric field, if you bend it into a semicircle, electric field should remain unchanged. Okay, mathematically it is very tricky to do that. You have to take a small portion of this wire, okay, then you have to do the integration, and that will be very, very long process. Okay, it is not a very simple question if you consider only merit of the problem, but this is a simple trick to remember that if the wire is long, if the electric field is given, then even if you bend it, the electric field should remain the same. That is a trick that you can remember. Now next question, a cubical Gaussian surface has a side of length A equals to 10 centimeter. Electric field lines are parallel to x-axis, as you can see in this question. The magnitudes of electric field through a surface ABCD and EFGH are 6 kilonewton per coulomb and 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube is. So this is also a little tricky and slightly difficult, but if you follow the process, it should be not that difficult. It is a medium to difficult level question. Mathematically it's a little bit more lengthier, but if you solve it, it will not be very complicated because values are given really good. If you start solving it, it should not create any problem. So here it is mentioned that ABCD is one surface and EFGH is another surface. Okay, so electric flux through ABCD is 6 kilonewton per coulomb. This one is 6 kilonewton per coulomb, and through this surface is 9 kilonewton per coulomb. Okay, now so this is the electric flux, okay, and electric flux is this way, it is going in, and this way it is coming out. So out flux is more than incoming flux. Outgoing flux is more than incoming flux. That means the charge inside must be a positive charge. So charge inside must be a positive charge. If the incoming flux is more than outgoing flux, then you can say that okay, the charge inside is negative. So understand that positive charge means, charge positive means net outgoing flux is positive. Okay, negative charge means net outgoing flux is negative. Now what is flux, by the way? Flux is very simple. So flux in this side ABCD is flux in. Okay, ABCD. Flux in is given by the area times the total flux. Okay, sorry, electric field is given, not flux is given. So electric field into surface area is the net flux. It's a plane surface, angle is same, so theta is 0, so cos theta is 1. Electric field is 6 kilonewton. Kilonewton means 10 to the power of 3. Okay, and what is the surface area? Surface area is, it's a cube, so all sides are 10 centimeters. So surface area, let me calculate the surface area first. Surface area is 10 into 10 into 10 to the power of minus 4. Okay, because we are calculating area, so it will be centimeter square. Centimeter square to meter square you have to convert. So 10 to the power of minus 4 is there. So it will be 10 to the power of minus 2 meter square. So if you can calculate them quickly without using any calculation like that, if I am solving it, I will know, okay, 10 centimeter means 10 to the power of minus 1, 10 to the power of minus 1 into 10 to the minus 1, that means 10 to the power of minus 2 meter square. Always convert the units into SI unit. That is one more aspect of solving. So from here we say that, okay, 10 to the so it will be 60 kilonewton meter square per coulomb. Okay, so this is the incoming flux. Unit is not important because you are solving for KCET. Okay, so this is the incoming flux. What is the outgoing flux? Outgoing flux is for surface EFGH. So EFGH, you have outgoing flux. Okay, that is phi out, and that is given by 9 into 10 to the power of 3 into 10 to the power of minus 2. Area should be same, so it is 90. Okay, 90 SI units. So we have calculated incoming and outgoing flux. What is the net flux? Net flux here is phi out minus phi in, which is 90 minus 60, that is 30. Okay, now what is the flux given here? Flux given here is obviously Q upon epsilon naught. Okay, Q enclosed by epsilon naught. So Q enclosed must be equals to epsilon naught phi. Now if you see in the question, epsilon naught's value is specifically mentioned 9 into 10 to the power of minus 12. So we will use that value. So Q equals to 9 into 10 to the power of minus 12 into 30. So it will be 270 into 10 to the power of minus 12, or 0.27 into 10 to the power of minus 9, or 0.27 nanocoulomb. So it will be 0.27 nanocoulomb. So as I mentioned, the problem might be little lengthy. You have to calculate incoming flux, you have to calculate outgoing flux, find the difference, and then use Gauss's law to calculate the charge. But mathematically not super difficult. If you calculate the values, if you understand the problem, if you know how to solve it, you can solve this question under 2 minutes. Okay, lengthy question, but under 2 minutes is still fine, because there will be many questions that you can solve under 10 seconds, 20 seconds as well. So if you manage your time properly, you will get enough time to solve these kind of questions as well. So keep that in your mind as well. Now, under electrostatic condition of a charged conductor, which among the following statement is true? So here we have 4 statements, one of them must be true. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where sigma is the surface charge density. The electric potential inside a charged conductor is always 0. Any excess charge resides on the surface of the conductor. Net electric field is tangential to the surface of the conductor. Okay, let's see. Sir, what would happen if a infinite charge plane sheet is bent into a cylindrical wire, inspiring from question number 9? So if you are considering a very infinite sheet, okay, first of all, if you bent it, you cannot the radius of that sheet will also be infinite. Okay, so even if you bend it in a finite circle, okay, if you go closer to the surface, it will be still give you a constant electric field. Further away, maybe some different value, but if you are bending, first of all, if the sheet is still infinite, you will get infinite length of what should I say, infinite radius. If you take portion of this, bend it into a suppose the plane is infinite. Okay, now if you bend it such a way that you bend it only portion of it, remaining still remains same, then if you measure the electric field closer to the surface, you will still get constant. Okay, further away also you will get the constant. Okay, because this effect will be negligible compared to the remaining portions. Okay. Sir, if I take ABHYAS today, 25th days falls on 28th, so can I attempt that test after final exam? You can take ABHYAS test as many times as you want and when you want. Okay, there is a schedule. Obviously you will not get the entire test series on the day 1, but you will get according to the schedule. You can attempt it any day anytime as of your choice. Okay, once the question paper is available to you, you can attempt the tests any day, any time you want. Okay, you can take it on the day before your KCET exam, you can take after your final board exam, you can take it after your final board exam is over. Say after final board exam is over, you want to relax for a day or two, then also you can attempt KCET. It does not matter, but you should finish, if you are taking the ABHYAS test series, you should finish the ABHYAS test series at least 2 times, so that you get a confidence that okay, I am ready, I am prepared, I can solve all the questions that is going to come in KCET, and I am ready with the time management. The main part ABHYAS gives you, the question paper level is so accurate that you are basically going to get the similar paper, obviously not the same questions, but you will be able to recognize, okay, this is a difficult question, this is an easy question, so in this question I should invest some time, I should save some time on these questions. Okay, that's how you should manage your time. So 60 minutes, 60 questions, if you are able to solve in ABHYAS, you should be easily able to answer all the 60 questions in your KCET exam paper as well, because many students are very good, they are outstanding, but they do not practice the time management, and then they falter. Okay, time management is one of the important aspect. 11C, yes, any excess charge resides on the surface of the conductor, so 11C is correct. Now another very important interesting question, a uniform electric field vector E exists along the horizontal direction. Okay, as shown, the electric potential at A is VA, electric potential at A is VA. A small point charge, small q, is slowly taken from A to B along this curved path. Okay, the potential energy of the charge when it is at point B. So potential energy of the charge when it is at point B. Now remember, potential of B is not given. Potential of B is not given, electric field is given, distance between A and B is given, but potential is not given. If the potential was given, this would have been a only one line question. Potential energy at B will be charge times potential of B. Okay, so this would be the answer, but VB is not given in the question. VA is given, E is given, and the distance X is given. Now what should be the answer? Let's see. I will solve, you try to solve along with me and answer it before I finish it. So electric potential at A is VA, electric potential VB we do not know, we are assuming obviously VB, electric field is given E, and distance between them is X. Okay, so we know that difference in potential VB minus VA, final minus initial, divided by the distance between the points, direct straight distance between the points, equals to minus E. Okay, so E equals to minus dV by dx or del V by del x. Okay, so we are using this concept. Negative sign I have taken on the other side for our convenience. Okay, so from here we can say that VB minus VA. Now whenever you are calculating the potential difference, remember you have to always calculate final minus initial, final minus initial, and we are moving in the direction of electric field, so VB must be equals to minus E into X, or VB equals to VA minus EX. Now is it correct or no? How to check that after calculating this if it is correct or wrong? So if you see that electric field is pointing from A towards B, electric field is in this direction, that means potential of A must be bigger, potential of B must be smaller. So suppose this is 10, this should be 8, so that's what we are getting. So VA is greater than VB, so our calculation is correct. Okay, if you follow the process, you will always get the answer correct. Now as we have mentioned, electric potential energy is very simple, it must be equals to Q into VB. VB is VA minus E into X, so correct answer is Q into VA minus EX, that is option D, not option A, not option B, but option D. Yes, Kishore is correct, Manjunath is correct, Supriya is also correct. Now, next question. A parallel plate capacitor of capacitance C1 with a dielectric slab between its plate is connected to a battery. It has a potential difference V1 across its plates. When the dielectric is removed, the potential difference are now C2 and V2 respectively. Then what is the correct relation? Okay, so here we have basically a parallel plate capacitor. Initially it had a dielectric medium between the plates. Okay. Now here the battery is, understand the question, battery is connected to a potential difference V1, so obviously the voltage will be V1, capacitance is given as C1. Now if you read the question carefully, this is not a JEE question. When the dielectric is removed, potential difference, dielectric is removed, battery is still connected, it is not disconnected from the battery. Okay, it is connected to a battery, it has a potential difference V1 across its plates. So that means the battery will also have potential V1. Now the battery is not disconnected. If the battery is disconnected, the answer would be slightly different. In this case, battery is still connected with this capacitor, only we have removed the dielectric. Only thing that happened is we have removed the dielectric, that means the battery is still connected, so the potential difference should still remain same. Okay, so V2 and V1 must be equal. V2 and V1 must be equal. Why? Because it is not removed from the battery. Nowhere it is mentioned that the capacitor is disconnected from the battery. Those kind of questions can be asked in KCET, but not mathematically. Again, like analytical questions. In JEE, they will ask you questions based on calculations. Okay, but we know that if you remove the dielectric slab, the capacitance decreases, so C2 must be less than C1. So C2 must be less than C1. Okay, so one of them should be C2. So let's see, everything should be 2. Okay, so C2 should be less than C1. So capacitance decreases, but voltage should remain same. So voltage should remain same, but capacitance decreases. So option D is correct in this particular case. Okay. Yes, Kishore, you are correct. Okay. Now 13, there are small typo over here, so it will be all the second ones should be 2, and based on that, not 13C but 13D. Okay, in this case they are saying, okay, sorry, my mistake. Yes, option C is correct. Option C is correct. C1 is greater than C2. C1 is greater than C2. Okay, C2 is less than C1 means C1 must be greater than C2. So option C is correct. Okay, so in this particular case, option C is correct. Now let's move on to the next question. The electric field and potential of an electric dipole along its axis vary with distance smaller respectively as. Okay, so here we are trying to find the electric field and potential of an electric dipole. It varies with R as. A easy question, we already know the answer, so I will wait and see your response. Yes, Rihan, option C was correct. Yes. So if you know, let me go back to the previous question. Just a second, my screen freezed. So if you see that here, what we have is capacitance is given by K A epsilon naught by D. Okay, capacitance is given by Ka epsilon naught by d. What is K? K is dielectric constant. Okay, K is dielectric constant. Okay, suppose you have inserted a dielectric constant is always greater than 1. Dielectric constant for free space or air is approximately 1. Any other medium than air and vacuum, it is always greater than 1. Okay, so dielectric constant cannot be a fraction. So if you have a dielectric medium, that means the capacitance has to be more than whatever it used to be with air. Air has dielectric constant 1, so you put 1 for air capacitors. Okay, so if you remove the so this is C1, C2 is only A epsilon naught by d, because you have removed the dielectric medium. Now it is only a simple air capacitor. So that means what you are doing, you are reducing the capacitance by K times. So C1 is actually C2 is actually C1 by K. Suppose it was 20, dielectric constant was 5, so C2 will be 4 only. Okay, so 5 you have to divide 20 by 5, that will be only 4. So basically it is reducing by a huge amount. So capacitance decreases if you remove the dielectric medium. Clear? Now let's move on to the next question. This is easy question. Janith is saying D 14th D. Okay, let's see. Question number 14D. Janith, let me check the other option. You are initially you are saying C, then you are saying D. Don't spam. Okay, option D for 14th. Let's see. So electric field and potential of an electric dipole along its axis. So electric field due to a dipole along its axis is given by 1 by 4 pi epsilon naught 2p divided by r cube, and electric potential on the axis of a dipole is given by 1 by 4 pi epsilon naught p by r square, p cos theta. Okay, cos theta is 0 for the axial position, so that will be p by r square. So electric field is varies with 1 by r cube and electric potential is 1 by r square. So option C is correct, not option D. Sorry, Jayatirth, your answer is correct or incorrect. Obviously, Kishore, it is my duty to explain all the things. If you don't understand, I will explain it once more. If you want, just mention that I am here. As long as I am here, I will explain it 2-3 times. Okay, so remember, normally electric field is 1 by r square and potential is 1 by r for a point charge. That is correct. But for a dipole, it is slightly different. For a dipole, that's why you have to read the questions carefully. It is electric dipole. For a dipole, electric field varies as 1 by r cube, electric potential varies as 1 by r square. So it is once r more than normally. So this is normal case. For a point charge, it is correct. But for a dipole, the calculation gives us that electric field is 1 by r cube and electric potential is 1 by r square. Right? Now let's move on. Two tiny spheres carrying charge 1.8 microcoulomb and 2.8 microcoulomb are located at 40 centimeter apart. The potential at the midpoint of the line joining the two charges is. Now you have to calculate it. So again, solve with me and try to answer before me. Right? So here we have two charges. One is 1.8, another one is 2.8. The distance is 40 centimeter. Remember, 40 centimeter means you have to convert back centimeter into meter. Okay, now we are trying to find electric potential at the midpoint. Okay, not electric field, electric potential, which is a scalar quantity. So you don't need to worry about direction, etc. You just need to calculate the electric potential and add them. So individually you can take this as a single charge, this also a single charge. Electric potential due to a single charge, say this is 1, this is 2. So V1 is given by K Q1 by R. Okay, both distances are same. Midpoint means both of them are 20 centimeter. Okay, so in that sense also it will be easy. So K is 9 into 10 to the power of 9, we all know. Q1 is microcoulomb, so 1.8 into 10 to the power of minus 6 divided by 20 into 10 to the power of minus 2. So don't forget this one, okay? Centimeter to meter. Now simplify. So 9 into 1.8 into 10 to the power of 11, 10 to the power of 5, 10 to the power of 5 divided by 20. Okay, so it will be, let's simplify, 10 to the power of 1 0 cancels, 4, we get 2.9, so 0.9 means 10 to the power of 3, so 81 into 10 to the power of 3. Okay, so this is the potential due to 1. Potential due to 2, V2 equals to 9 into 10 to the power of, so write directly, do not write the formula. Okay, you have to start writing the calculations directly. Avoid writing the formula, then only you will be able to save some time. So directly, this formula should be in your mind. When writing, you should directly write the values. So 9 into 10 to the power of 9, 2.8 into 10 to the power of minus 6 divided by 20 into 10 to the power of minus 2. Only charge will change, remaining things will remain same. So we can say that 9 into 2.8 will be 1.4 by 10. So 9 into 14 into 10 to the power of 3. So it will be 90 plus 36, 90 plus 36, 126 into 10 to the power of 3. So the net potential is V1 plus V2, that is 81 plus 126 into 10 to the power of 3, that is 207 into 10 to the power of 3. Okay, 207 into 10 to the power of 3 or 2.07 into 10 to the power of 5. So if you see which answer is correct, if you see the answers options, only one of them is correct, even though none of them are exactly matching your answer, but if you take approximation of 1 decimal only, you will get the answer, which is obviously option D, 2.1. Yes. Sir, please increase the speed, then we can solve more questions in less time. Jaitit, try to answer the question first correctly. Okay. Supriya is also correct. Now let's move on. Okay, let's solve the questions faster. A parallel, if the question requires time, you have to give me the time. Right? A parallel plate capacitor is charged by connecting a 2-volt battery across it. It is then disconnected from the battery and a glass slab is introduced between the plates. Which of the following pairs of quantities decrease? Now answer this question. Here we have a normal air capacitor, okay, and it is charged to 2-volt potential. Now the battery is disconnected. It is mentioned that it is disconnected. So battery is no longer part of this. Now initial capacitance C1. Now what you have done, you have inserted a glass slab between the plates. So glass slab is basically a dielectric medium. Okay, glass slab is basically a dielectric medium. So what is the new potential? What is the new capacitance? Okay, so let's see which pair of quantities decreases. They are asking you the quantities that is decreasing. Okay, definitely capacitance is increasing. So if you increase a dielectric medium, capacitance should be increased by K times. So capacitance is not decreasing. So capacitance and charge is wrong. Energy and capacitance must be wrong as well. Okay, so whatever portion they have capacitance, that should be wrong. So this is a way also of answering question by method of elimination. Okay, capacitance is increasing, so capacitance cannot be the correct answer for decrease. What else? We know that once you charge the capacitor, it is an isolated system. So isolated system means conservation of charge is also there. So total charge of the capacitor should also remain constant. So charge should not decrease or increase. Charge should remain the same. Okay, so if the capacitor is charged, you disconnected it, you added a glass slab, it does not matter, the charge should remain same. Okay, so charge is also not part of the correct answer. So Option A, option B, option C are eliminated. Potential difference and energy stored are decreasing. It is actually correct. Now how can we know that potential difference is decreasing? So whenever you are increasing the slab, what happens? Because charge is constant, charge is equals to CV. Okay, so C is increasing, so V must decrease. C is increasing, V must decrease. Similarly, energy stored is half CV square. Energy stored is half or you can say half Q into V. This is also a formula. So Q remains same, so V is decreasing. That means energy stored should also decrease. Energy stored should also decrease, right? So either you can answer directly, okay, capacitance increases, voltage should decrease, and energy is half Q into V, Q is constant, so V must decrease. So that is also a way to answer it. Or you can realize that capacitance is increasing, capacitance should not be the correct answer, charge remains same, so charge should not also be the part of the answer. So this is also a way to answer, right? Option D. Next question. If a slab is of insulating material 4 into 10 to the power of minus 3 meter thick is introduced between the plates of a parallel plate capacitor, the separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meter to restore the capacity of the original value. The dielectric constant of the material will be. There is a shortcut trick you can use that to calculate the dielectric constant. Let's see who knows that. Right, let me have some water. Yes, E is equal to half Q into V. Now answer this question. So here the question is, initially we have a capacitor, okay. Now inside the capacitor plate we have introduced a dielectric slab, say of dielectric constant K, of thickness. The thickness of the dielectric medium is T, which is given by this value, 4 into 10 to the power of minus 3 meter. But to keep the capacitance constant, what we have done, we have increased the distance between the plates. Okay, we have increased the distance between the plates so that the capacitance remains constant, and that increase is given by, that thickness is given by 3.5. So that thickness, say, is D, small d, okay, small d. Then what will be the dielectric constant of this material? Okay, what should be the dielectric constant of this material? So the formula, the shortcut formula is 1 equals to let me see, 1 by C equivalent equals to 1 by C1 plus 1 by C2. Okay, and this one is 1 by C. So, and that 1 by C is still here. 1 by C is equals to Ka upon d into epsilon naught. This one is Ka epsilon naught by, this one is T, right, T, and this one is Ka, not K, A epsilon naught by D, right. It will be T by K plus D by K plus D equals to T. Okay, the shortcut formula that you have to remember is this one, or you can do one more thing that the way I have figured it out. The capacitance normally with the dielectric is Ka epsilon naught by this thickness. Now when you are connecting them like this, there is a dielectric medium and there is a air medium. So this is basically can be considered of series combination of two different capacitors. So this one is C1, this one is obviously C, this one is again C, this capacitance should remain same, this one is C1. Okay, so now what is happening here, you have to understand that after adding also you should get back the old capacitance as well. So the equivalent capacitance of these two should be equals to C, and that's how I have calculated this formula, which is T equals to T divided by dielectric constant K plus D, okay, or T minus T by K equals to D, or T is common, 1 minus 1 by K equals to D. Okay, so from here also you can simply, don't worry if you are not able to solve this question using this method. I am giving you the shortcut, you can use that to solve this question. Okay, the shortcut formula is 1 minus 1 by K equals to D by T. Okay, so D is given here 3.5 and T is 4. Now remember, both of them 10 to the power of minus 3, so you don't need to worry about it. So 1 minus 1 by K equals to 7 by 8, or 1 minus 7 by 8 equals to 1 by K. So just exchange the sides and we get 1 by 8 equals to 1 by K. So K equals to 8. Okay, this is the formula that you should remember. This formula you should remember. Okay, for a dielectric medium, when you are adding a dielectric medium and some air, then to keep the capacitance constant, you have to find T into 1 minus 1 by K equals to D. Okay, or you can remember this formula as well, whatever you are comfortable with. Okay, so here the dielectric constant is 8. Now this formula, something that we have learned, it is not there in your NCERT. So if you are studying from only NCERT, you have to use this long method, and this can be tricky. C epsilon naught A by D, it is for air capacitor. C epsilon naught A by D is for air capacitor. So this is the A epsilon naught by D is for air capacitor. When you are inserting a dielectric medium, it will be Ka epsilon naught by D. Okay, with the dielectric medium it is Ka epsilon naught by D, with air only A epsilon naught by D. Okay, now the thickness of this one and this one are different. So this one is with T, this one is with D. Okay, now after increasing this distance, the overall capacitance remains constant. So overall capacitance remains constant means the series combination of this capacitor plus this capacitor should be equals to this capacitor. Okay, and this capacitor is exactly equals to this. Okay, so if you compare these two equations, K epsilon naught by D will cancel, A epsilon naught by D will cancel, and you will get this relation. Okay, you can try it at home. You can try this method. You can download the PDF later on and you can see whether you are able to solve this equation or not. Otherwise, as I mentioned, you can remember this formula. Next, 8 drops of mercury of equal radii combine to form a big drop. The capacitance of a bigger drop as compared to each smaller drop is. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 drops of mercury of equal radii combine to form a bigger drop. The capacitance of a bigger drop as compared to the each smaller drop is. Now capacitance of a spherical capacitor is proportional to its radius. Okay, capacitance is proportional to its radius. Suppose the smaller spheres have a capacitance of C1 and each of them has, say, a radius of small r. Okay, so each of them have a radius of small r. C1 must be proportional to small r. Okay, now when they all form a larger drop, say the new radius is capital R and the new capacitance C2 should also be proportional to capital R. Okay, so C2 by C1 is capital R divided by small r. So if I can find this relation, I will be able to say that C2 is this much bigger or this much larger than C1. Okay, now how to do that? How to find the relationship between small r and capital R? So what is the volume of a sphere? Volume of a sphere is 4/3 pi r cube. Okay, for a smaller sphere, volume is 4/3 pi small r cube. Now how many of the smaller spheres are there? Total sphere is 8. Now these all small spheres are combining to forming the larger sphere, right? That means for larger sphere the volume, total volume should be equals to addition of each of the sphere's volume. So it will be 4/3 pi capital R cube. So 4/3 pi cancels and we get R is equals to 2R. Okay, so capital R is only twice of the small r, so it will be 2R by R, so that is equals to 2. So the capacitance is only 2 times. Capacitance is only 2 times larger. Yes, Kishore is correct. Supriya is also correct. Yes, you can use that formula as well. No, C dash equals to epsilon naught A by D minus T plus 1 by K. Okay, I have to check that, Kishore, if that formula can be used or not. I have to check. But here you are assuming the entire length is D. Okay, here I am assuming D and T separately. Electrician requires a capacitance of 6 microfarad circuit across a potential difference of 1.5 kilovolt. A large number of 6 microfarad capacitors which can withstand a potential difference of not more than 500 volt are available. The minimum number of capacitors required for the purpose is. Very interesting, slightly lengthy, but very interesting question. One of my personal favorite question in entire KCET previous year papers. Okay, try to answer this question. Sir, there is V and C formula for this kind of question. Yes. Answer it. Answer this question. This is, as I mentioned, is one of my favorite question, very close to my heart. Okay, slightly older but very interesting. The similar type of one question came in Comet K also. They tried to make it little difficult by giving the question in terms of combination of cells. Okay, similar question came in combination of cells, not from this chapter. Comet K, those who will prepare after, obviously after KCET, if you want to prepare for Comet K, then also you will face similar question. Quickly. So here if you see the question carefully, it is mentioned that the power requirement is 1.5 kilovolt and the capacitor can only withstand 500 volt. So that means it is not only series combination or parallel combination of capacitors. First thing you have to figure out how you can withstand 1.5 kilovolt using 500 volt capacitor. 1.5 kilovolt means what? 1.5 kilovolt means 1500 volt. Okay, 1.5 kilovolt means 1500 volt. So basically, to handle voltage, maybe it's resistor, maybe it's capacitor, they always have to be connected in series. Okay, so that the voltage drop equally distributed among them. So now if I connect 3 capacitors in series, each of them will be having 500 volt. Okay, so they can now withstand the required 1500 volt requirement. Okay, but if we connect capacitors in series, the overall capacitance decreases. Okay, but our goal is to increase the capacitance. We are trying to find 6 microfarad. Each of these capacitors are 2 microfarad, 2 microfarad, 2 microfarad. They are connected in series. What will be the equivalent capacitance? 1 by C1 plus 1 by C1 plus 1 by C2. Each of them are same, so 1 by C plus 1 by C plus 1 by C. So you will get equivalent capacitance of this particular combination as 2/3. In series combination of capacitance, capacitance decreases. Okay, so you have to connect them first in series to handle the voltage. Now this each branch have this much of capacitance. Now we will connect more such branches in parallel so that we get the exact 6 microfarad capacitance. So now we have, suppose we have connected n number of such cells in parallel, n number of such capacitance in parallel. All of them have 3 capacitors. Okay, so that our equal capacitance is 6 microfarad. Okay, so now let us see how many such rows we need. Okay, n number of rows, each of them have 2/3 microfarad. So total capacitance that we require is 6 microfarad. We have n number of rows, each row have 2/3. So in parallel combination, resistances simply gets added. If n number of capacitors have same capacitance, you can simply multiply them with n. Okay, and you can calculate n equals to 6 into 3 divided by 2, that is 9. Now if you answering after solving up to this point, if you mark your answer 9, you will be wrong. They ask you the minimum number of capacitors. So 9 such row is there. Each row has 3 capacitors. 9 rows and each row has 3 capacitors. So total number of capacitors is 9 into 3. That is, you require at least 27 capacitors. You will require at least 27 capacitors, not 3, not 9, but 27. Okay. For capacitor in series, C equivalent decreases. Yes. Shaila is saying 27 is correct. Supriya is also correct, 19D. Okay, so here you have to be careful that first of all 3 capacitors in series. Okay, overall capacitance decreases but voltage rating is matched. Once voltage rating is matched, now you take all 3 such capacitances and connected them in parallel, because they have said a large number of capacitors. You don't need to worry that how many capacitance you need. Only major worry is to handle the voltage and get the final capacitance. Okay, first you connect them in series to handle the voltage. When voltage is handled, then you connect them in parallel to increase the capacitance. Total capacitance, you have to, again, don't make a mistake, you have to multiply the final 2 results to get the final answer. Now next question. In figure, charge on the capacitor is plotted against potential difference across the capacitor. Here is the diagram. The capacitance and energy stored in the capacitor are respectively. So here is the diagram that capacitor is storing charge. 120 microcoulomb charge is stored at 10 volt. 120 microcoulomb is stored at 10 volt. You have to calculate the capacitance and energy stored. Capacitance and energy stored. Easy question, not very difficult. Either 12 or 24 should be the capacitance, and energy should be either 1200 or 600. Let's see. This year my elder brother gave KCET. Yes, 19th question, that's why I am saying how C is equal to 2 by 3. So if you go back here, 3 capacitors are connected in series. 3 capacitors, if you connect, so this is a shortcut here as well. So if you connect, say, X number of capacitors in series, each of them have same capacitance, the equivalent capacitance is basically 1 by C equivalent equals to 1 by C plus 1 by C plus 1 by C plus dot 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 1 by C, right? How many times? X number of times, 10, 20, 15. So you are basically adding them X number of times, that means it will be X by C. Right? C is common LCM, 1 plus 1 plus 1 plus 1 plus 1 plus up to X time, so it will be X, right? So X by C. So C equivalent here will be C by X. C by X. This is valid when all of them have same capacitor. All of them have same capacitance. Here we are connecting 3 capacitors in series. 3 capacitors in series, each of them have 2, 2, 2. Okay, each of them have 2, 2, 2. How many? 1, 2, 3. So capacitance divided by number of capacitance, that is 3. Okay, capacitance of any one divided by number of capacitors, that is 3. So 2 by 3 is the equivalent capacitance, and it is not the for entire row, this is only for this much. Okay, for entire row is 6, that is given. Okay, this is only for this column. Okay, for this row only. Entire column if you consider, then you have to add the series parallel combination formula. Parallel combination, n is multiplied. For series combination, n is divided. Okay, so remember this shortcut. If you are solving problems with same capacitance, you can simply take the capacitance, divide by the number in case of series, multiply by the number for parallel. That's it. Kishore is saying 20th B. Okay, Shaila, I hope your answer is cleared. Shayal Ahmed. Okay, Shayal Ahmed. So what is the case over here? So capacitance is Q by V. So charge stored is 120 and voltage is 10, so it will be 12. Okay, so 12 microfarad is the capacitance. What about the charge stored? Energy stored. Energy stored is Q into V. Okay, so half into 120 into 10, that is 600 microjoules. Okay, so what we will be taking? We will be taking this value. Okay, for 10 volt 120 microcoulomb. For 10 volt 120 microcoulomb. So you can use capacitance formula to calculate the capacitance, and energy formula to calculate the energy stored as well. So it will be 12 microfarad and 600 microjoules. So option B is correct. Option B is correct. Yes, Kishore, Manju, ND Manju, I think Manjunath, but from a different account, I hope. Now, in the following circuit, the terminal voltage across the cell is. So terminal voltage across the cell is. So here is the terminal voltage. So you have to find the voltage between this, or voltage between the resistance as well. Terminal voltage means voltage between these 2 points. You can calculate voltage from here, or you can find the current and multiply with the 3.9 to calculate the terminal voltage. Terminal voltage, because this is the resistance, so whatever current is passing through the circuit, if you can calculate the current, you can easily find the terminal voltage as well. A few moments back I saw Saini ma'am here also. Yes, Saini ma'am, how are you? Sir, this year they increase the level of JE. Will they also increase the level of KCET? So there is no correlation between JEE and KCET. JEE and NEET generally are slightly correlated, okay, and JEE also in some session the paper was easy, in some session paper was slightly tricky, so it varied from session to session. For example, one session physics was very easy but maths was very difficult, so it can vary from session to session, okay. In one session I heard physics was difficult, math was okay. So overall level I have not checked the questions, I have seen only 2 or 3 session physics papers, but anyway, KCET and JEE is not related. JEE and NEET is somewhat related. Last year they have increased the level of NEET. Maybe if you are appearing for NEET, the level may be little difficult this year again, but KCET should not be hampered. KCET level should be almost same. Okay, as I mentioned, KCET level they have very strict guidelines that out of 60 questions, okay, 30 questions will be easier, 20 questions will be medium, 10 questions will be slightly lengthy, in your terms difficult. But true difficult question in the entire KCET paper should be limited to 1 or 2, which you will not be able to solve even if you invest a lot of time during the exam hall condition. Only the toppers and the super genius students will be able to solve them. Normal students, it will be very difficult for them to solve those 1 or 2 questions. So if you skip those 1 or 2 questions and remaining 58 questions, if you are able to answer, then definitely you will be a very good shape compared to other students, those who invested time to solving those difficult questions. Okay, so that is a smart strategy that you should take. So now, so 2V 0.1, 3.9. So the total resistance of the circuit, total resistance say R equivalent of the circuit is small r plus capital R. Small r is 0.1, capital R is 3.9. So the total resistance is 4 ohm. The voltage is 2 volt. So current in the circuit is voltage, so not voltage, I should not say voltage, it is the EMF. So EMF divided by R equivalent, that is the current, okay. So EMF is 2 and resistance is 4, so 0.5 is the current. So what is the potential drop? Either you can multiply 0.5 with 3.9 to calculate, or another way is to find the voltage is epsilon minus I into small r. In this particular case this is easier, okay. So epsilon is 2 volt minus current is 0.5 and the small r is 0.1, that is 2 minus 0.05, that is 1.95. 1.95 volt is the terminal potential, okay, easy. Sir, if we study these questions, is it enough? It is just a practice. This is not enough, obviously. This is just to practice, to give you an idea, the level of the question, the topics that you are missing out, the concepts that you may not have studied, whether you have to study those concepts. So remember, questions are not repeated, concepts are repeated. Okay, so if you, these are basically giving you some idea. For example, you have solved one capacitor based question, which is basically giving you an idea, okay, this type of question may also come. Okay, so you have to prepare yourself and solve some questions. If you see some difficult question, you are thinking that difficult question do not come in KCET. That is not true. So that is basically, it will give you an idea. Suppose you are answering this question, now ask yourself, am I able to solve it, the question without any help or not? Most of you have seen some of the PYQs, most of you have answered some of the PYQs, but still you are making some mistakes. I have seen some, not you maybe, but some other students are making mistakes. So you have to answer these questions freely. Then only you will say, okay, I am ready for KCET exam. If you are not able to answer this question, if you are answering these questions from your memory, then maybe you are not ready. If you are able to answer these questions freely without taking any help from memory, then you will be able to answer it. Two cells of EMFs E1 and E2 are and internal resistance R1 and R2, E2 is greater than E1 and R2 is greater than R1 respectively, are connected in parallel as shown in the figure. the equivalent EMF of the combination is E equivalent, then which of the following answer is correct? NCERT exemplar is a good option, but it has a limited number of questions, and frankly speaking, the book has not been updated for over more than 5 years. More than 5 years back, whatever book I have seen, the same book they are using today as well. NCERT textbooks are updated, but exemplar book was not updated, so that is one issue with that book. Some questions are outdated, some questions are I have found some questions which are currently out of syllabus as well. Okay, so NCERT exemplar, they need to update it, they need to add more questions to it, more relevant questions to it, then only it will be more appropriate. Okay, NCERT exemplar, I like the book. By the way, the book is right now still it's good, but the book is slightly outdated in my opinion. Last year paper was easy, Kishore. Last year paper was almost very easy. Okay, the paper that I discussed in my lecture, that student also got 60 out of 60. The paper discussion, we collected the paper from one of our Deeksha student, and that student also got 60 out of 60. Okay, many students got 60 out of 60. Two cells of EMF, you need to know how to solve this question, answer this question. I still have 7 more questions after this, so I have to answer it quickly. So here, this question you will not be able to solve if you try to even put your head in the wall. So that so what you have to do, you have to, so in such cases, what you have to do, you have to take some real values. Okay, if the question is completely abstract and they ask E1 greater than E2, what about equivalent EMF, what about equivalent resistances? So in that case, what you have to do, you have to take some real examples. So say it mentioned that E2 is greater than E1. So let's say E1 is 1 volt, R1 is 1 ohm. Okay, E2 is 2 volt and R2 is 2 ohm. So this both conditions are satisfied over here. So whatever we will get from this problem, should be universal. Okay, we are taking values according to this condition. So if we try to solve it, we should get an answer which is universal. Now equivalent EMF is given by E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. If you remember this way, it is very easy to remember. Okay, E1 is 1 by 1 plus 2 by 2 divided by 1 by 1 plus 1 by 2. So we get 1 plus 1 divided by 3 by 2, that is 4 by 3. So that will be 1.33. So equivalent EMF is 1.33 volt. Okay, so as you can see, 1.33 is between E1 and E2. So 1.33 is between E1 and E2, so that means option C or option D must be correct. Okay, here it is said E1 less than EQ less than E2, so that should be the correct answer. Okay, now but there is also one other option is that, and E equivalent is nearer to E1, E equivalent is nearer to E2. So 1.33, is it nearer to 1 or 1.33 is nearer to 2? So if you see the difference between 1 and 1.33, it is 0.33. Difference between 2 and 1.33 is 0.67. So definitely it is closer to E1 than E2. Okay, so E1 E equivalent is between E1 and E2, and E equivalent is nearer to E1. Okay, so this is also very interesting, and even though no values are given in this question, you can take any arbitrary chosen values according to the given condition. We have taken the simplest possible values so that we don't want to do too much mathematics, so we have taken the simplest possible values. Now you might say, sir, what will happen if I take 10 volt and 1 ohm or 20 volt and 2 ohm? You can take any value if you want. Okay, as long as this number is smaller than this number is smaller than this number. That's it. But we have chosen the values such that it is the smallest value and satisfying the condition. Number is easy, so 1 by 1, 2 by 2 cancels, and our calculation is easier, and we get one value, and we understood that this value is coming between these two values, and this value is closer to the smaller EMF. Clear? Clear? So you have to take some not random values, some values 1, 2, 1, 1, such a way that the number is not too big, and you are, when if you recall this formula, you should remember that if I take E1 and R1 both 1, E2 and R2 both 2, then our top part is sorted, right? So we get in the top, we are getting 2 only, 1 by 1 plus 2 by 2, that is 1 plus 1, that is 2. And in the denominator we are getting 1 plus half, that is 3 by 2. So numbers are easy, only thing, and even after solving you are getting 4 by 3. 4 by 3 is also an easy number, 1.33. So don't take too big numbers, only small numbers which you can handle quickly and solve simply. Okay, so this is a very tricky question in this year, but mathematically not difficult if you know how to solve it. Tricky question is very, very tricky. Without taking these values, you will not be able to solve it mathematically. Now, this question is easy. Okay. Any other reference you can practice questions from MTG, but MTG is too much, right? At this moment MTG is too much. MTG is basically a 2-year whole full year course. Okay, the book is so heavy. If you are starting now, MTG will be too much. You can practice compared to that. If you practice from our ABHYAS, the total cost of 3 MTG books will be more than our 1 ABHYAS textbook. Okay. Now let's see the variations of resistivity rho with absolute temperature T for 3 different materials X, Y and Z are shown in the graph. I have discussed the similar question in my Masterstroke lecture. So let's see how many of you can answer this. Identify the materials X, Y and Z. X equals to semiconductor, Y is equals to nichrome, Z equals to copper. X equals to nichrome, Y is copper, Z is semiconductor. So basically we have 3 materials. One is a conductor, one is a semiconductor, one is a nichrome, which is an alloy. Okay, alloys generally have a constant resistivity. Semiconductors resistivity decreases with temperature, and for conductors like copper, resistivity increases with temperature. Here we have resistivity. Okay, very, very careful. Next year maybe the same question will be asked with conductivity. The graphs will be completely changed. Okay, so you have to be careful. Yes, this question is directly from NCERT with slight variation. Okay, in NCERT they have mentioned conductor, semiconductor and alloy. In this case they have given direct example of copper, nichrome and semiconductor. That is the main difference. Okay, now Shamit is saying option C, then change to option B. Shaila is saying option C. So X is copper. X is copper, its resistivity is increasing with temperature, so this must be the copper conductor. Z must be the semiconductor, and this one must be the alloy, which is nichrome. Okay, so copper, nichrome, semiconductor. So correct answer is option C. Copper, because its resistivity is increasing with temperature. This is semiconductor because its resistivity is decreasing with temperature, and this one is basically constant, almost constant. Next, given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of the wire? Current and drift speed, current only, current, electric field and drift speed only. Okay, which one is current? Given a current carrying wire of non-uniform cross section. Non-uniform cross section means, suppose this is a wire. Normally uniform cross section means this is a uniform cross section. Okay, but non-uniform means, suppose the wire is bent over here, it is bulged over here like this. So it has some area, different area of cross section and each and every point. So this is called a non-uniform conductor. Okay, non-uniform conductor, it is carrying some current. Which of the following quantity is constant? Okay, so this is current, drift speed is in opposite direction of the current, and electric field is also in the direction of current. Which of the following is constant? Shaila Ahmed is saying current only, option B. So only current will remain same. Only current will remain same. Okay, I equals to NEA VD. Now A into VD is constant. Okay, this is the equation of continuity. So this is basically constant. Current is constant, number density and electron is constant, so current should be constant in a wire. Electric field will change based on the area. Okay, drift velocity will change depending upon the area as well, but the current in a conductor is constant. Current in a conductor does not depend on the cross section, it only depends on the potential difference and the resistance of the wire. Even if it is a non-uniform wire, resistance, total resistance of the wire is constant, total voltage that you have applied is constant, that means current should also be constant. Now next, the graph between variation of resistance of a metal wire as a function of its diameter, keeping other parameters like length and temperature constant is. So in this case, what we are varying resistance and diameter. Resistance and diameter. Now you might be wondering, sir, resistance and diameter are not directly related. Yes, they are related. So we know that resistance is given by rho L upon area A. So if you know the area A, this is the diameter. So area is basically pi d square by 4. Okay, area is pi d square by 4. Area of a circle is pi r square. R is d by 2. So whole square pi d square by 4. So resistance is given by rho L divided by pi d square by 4. Now if you see that everything else is constant, rho is constant, L is constant, pi is a natural constant, 4 is also constant, so we can say that resistance is inversely proportional to the square of the diameter. Resistance is inversely proportional to square of the diameter, so option 2 is correct. Now one very important tip to all of you, if you see a graph based question like this, and if you are somehow not sure which of the graph is correct, then if you see a graph of pattern this way, then there is a 80% chance that this is the correct answer. Out of last 10 years papers, I have seen that only once this was not the correct answer. Okay, otherwise if this pattern is there, maybe electric field, maybe electric potential, maybe some other question, this could be the correct answer. So if you don't know the answer, you don't want to invest too much time, you should mark this pattern. Okay, this inverse square pattern or inverse pattern. Okay, inverse square and inverse are almost same. So this pattern you should mark if you are not willing to invest some time, and there is no negative marking. So even if you are wrong, you will not marks will not be deducted. If it is an easy question, you will be able to identify the graph properly. If it is a slightly tricky, difficult question, then somehow you have to mark this question, mark this option without trying to solve it. If you get time, you can solve it. If you don't get time, just mark it. Now, electric field E is inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J. Then the correct form of Ohm's law. Correct form of Ohm's law is J equals to sigma E. J equals to sigma E. But wait, that option is not given. This is the alternative form of Ohm's law, but that option is not given. Then what is the correct answer? Yes. Hello Kaveri. Sir, high weightage chapters of physics for KCET exam for both PU1 and PU2. Kaveri, PU1 chapters you should any chapter of PU1 is low weightage compared to your PU2 chapters except electromagnetic wave chapter. Electromagnetic wave chapter only one question comes, and maximum number of questions that you can expect from PU1 is only 2 questions. Okay, that is motion in a straight line, motion in a plane, laws of motion, and I think gravitation, and system of particles. Okay, these 5 or 6 chapters from where you are getting 2 questions each. In second PU, all chapters are more weightage than any of your PU1 chapters. Minimum 2 questions will come from each chapter, minimum, except electromagnetic wave chapter. Electromagnetic wave chapter only 1 question will come. Okay, now if you consider the highest weightage, obviously current electricity, the chapter questions that we are solving right now, from that chapter alone you are going to get 6 questions. Then we have electric charges and fields chapter, 4 questions. Electrostatic potential and capacitance, minimum 3 up to 4 questions. Ray optics, 4 questions, 4 to 5 questions. Okay, then we have moving charges and magnetism, another 4 questions. We have alternating current, 3 questions. We have wave optics, 3 questions, dual nature, 3 questions. Atoms and nuclei, it was used to be 3 and 2. Now last year onwards it is 2 and 2. So each chapter is going to give you 2 questions. Semiconductor is also, last year number of questions is reduced to 2 questions because semiconductor has lot of deleted questions. So from there also they have removed few questions and added in the experiment section. From experiment you are going to get 3 questions. Okay. So this is the weightage of the chapter. So high weightage chapter means electric charges and field, electrostatic potential and capacitance, current electricity, moving charges and magnetism. Okay, then you have ray optics and alternating current. Okay, these are the important, most important chapters. You cannot skip any of these chapters. First PU, even if you skip, you will maybe losing out 17-18 marks. Okay, remaining 40 marks, 42 marks questions will come from your PU2 alone. Okay, so first you focus on finishing all the chapters of your PU2, then you study the chapters of PU1 as I mentioned. Other chapters of 11th, you will get 1 question from all the remaining chapter, units and measurement. Okay, then you have work, energy, power. You also have properties of solids, properties of liquids, kinetic theory, thermodynamics, thermal properties, waves and oscillations. From all chapters you are going to get 1 question each. Okay, so 14 questions from 14 chapters, and 4 chapters, I think 4 or 5 chapters, they are going 2 questions. So total 19 questions comes from your PU1 last year. According to last year, 19 questions came from your PU1. Remaining 41 questions from PU2, including 3 experiments. So Kavya and Ash is saying option C. So option C, let's see. So option C, for option C you have to separate electric field E. Electric field E is 1 by sigma into J. Now 1 by sigma is nothing but resistivity, so it will be resistivity into current density. So correct answer is E equals to rho into J. Question number 27, very interesting question. In the circuit shown, the end A is at potential V0 and end B is grounded. The electric current indicated in the circuit. Okay, so this question, now I will tell you one thing. If you redraw this circuit, like this, then it will be very, very helpful for you. Okay, this portion of the circuit is nothing but this. Okay, and what is this? This is a simple Wheatstone bridge. This is a simple Wheatstone bridge. Each of them have resistances R. Now in this is a particular easy question. In next time maybe you will not see all of them are R. Okay, maybe some of them they might give this one small r. Okay, don't worry. This resistance does not matter. You might see this is R, this is 2R, this is R, this is 2R. Only thing that you have to be careful about is the ratio same. This by this, is it equal to this by this or not? If that condition is satisfied, then the Wheatstone bridge is balanced. So So Wheatstone bridge is balanced means no current is passing through the galvanometer. No current passing through the galvanometer means you can easily remove this central resistance. So this central resistance can be removed. Once the central resistance is removed, that means you cut it and remove it, you will see that these two are in parallel, these two are in parallel. So this, these two are in series. So this and this are in series. This and this are again in series, and their combination is in parallel. Okay. So R plus R is basically R plus R is equals to 2R, right? And this R plus R is again 2R. Okay. So this is also 2R. So 2R and 2R now in parallel. So 2R and 2R in parallel means what is the equivalent resistance? 2R into 2R divided by 2R plus 2R. That is will be equals to R. Okay, you can calculate 4 divided by 4, R square divided by R, so it will be simply R. Now if you see, now in future, I am just giving you a hint, in future if you see a similar diagram with all resistances same, then you don't need to do any mathematics. You will know this is a Wheatstone bridge, balanced Wheatstone bridge, and its equivalent resistance should be R. If all resistances are same, if all resistances are same except the central one does not matter, because this will anyway will be removed. This is a galvanometer portion, so this will be removed. So if you see that this is R, this is R, this is R, this is R, you don't need to think anything else. The equivalent resistance should be R for this combination. Similarly, now if you apply the same logic, everything is 2R, so equivalent resistance of this portion simply will be 2R. You don't need to do any mathematics. Okay, because we know again this is a Wheatstone bridge, this must be removed because it's a balanced Wheatstone bridge, and if all resistances are same, the equivalent resistance is also the same as any one of the resistor. Okay, equivalent resistance should be same as the one of the resistor. If they are not same, if it is R, it is 2R, this is R, this is 2R, then you have to use the series and parallel method to calculate the exact resistance. Okay, it can be any value, R, 4R, R, 4R. At least this ratio should be equals to this ratio. Okay, suppose this is 2R, 4R, this is R, 2R, then also it is balanced Wheatstone bridge. Okay, so you have to just be careful that the ratio should be same. If the resistances all are same, then just 1 second problem, this is R, this is 2R, so now these two are in series, so one R and another 2R in series, this end is grounded, this end is at plus V0, so R and 2R, so basically if you add them, the total resistance is equals to 3R. The total resistance equals to 3R. So what is the current in the circuit? Current is V0 minus 0 divided by 3R, that is V0 by 3R. Okay, so this is the current. So V0 by 3R, so option D is correct. Clear? Sir, please tell me how to access KCET PYQ from Google. I don't know, Kaveri. You can download last year's paper. There are few websites, they do give you KCET PYQs, but most of them are not authentic, and they you have to register in their website. They will take you have to fill up some forms, then only you will get the PYQs. You can download our PYQs. This PDF I'll make sure it is available to you through our WhatsApp channel. So if you join our WhatsApp channel, at least these many questions you will get. Okay, we have done our old KCET Sankal series. There we have done more PYQs. You can go and check that out as well. Okay, there we have done the PDFs was also available in our WhatsApp channel. So if you have joined our WhatsApp channel, you should not worry about KCET PYQs. If you purchase ABHYAS, you will get 10 years PYQs as a free of cost. So you will get them as in a quiz format. You can try your knowledge and practice them as a quiz format as well. Okay, that is one thing. If you are looking from Google, as I mentioned, there are few websites, they do give KCET PYQs, but those I have found many of those questions are irrelevant and not actually very good. They have added questions which are not there in the previous year paper. And also one more important thing is that if you try to go back more than 1 year, that is after from 2024 till backwards, if you go, there will be a lot of questions out of syllabus. 24 only had 9 questions out of syllabus. There was a huge problem back then in 24. Maybe you are giving your class 10th back then, maybe you have heard about it. Okay, so there was a huge cry about from the students that many questions are outside our syllabus. Okay, and before that, out of syllabus questions or part of the syllabus back then, so you will find a lot of questions. You may not be able to solve them, thinking that, oh, I am stuck at this question, how to solve this question. Basically those questions are out of syllabus. Okay, so you should practice questions which are currently in the syllabus itself. Sir, if we use parallel, we will get 4R, right? So parallel, so this is series, right? R and R is series, R and R is also series. Now they are in parallel. In parallel combination of resistances, resistance decreases. So you are making a mistake. In capacitance, it is getting added. Parallel combination of capacitor, resistance getting added. In parallel combination of resistance, resistances are added in inversely. So that means parallel combination R equivalent is this. Okay, so don't get confused. In series combination of resistances, resistance increases. In parallel combination of resistances, resistance decreases. Okay, so it will not be 4R but R. Okay. No, Shaila, it is for capacitance, not for resistance. That's what I'm saying. Yes, Ayush Gowda, it will be sent once the lecture is over. Yes, yes. So now let's see this question. Electric current flowing through a given conductor varies with time as shown in the graph below. The number of free electrons which flow through the given cross section of time of the conductor in the time interval 0 to 20 seconds. So if you see that a current is given in milliammeter, okay, and the graph is given, not the exact current. Okay, so we know that I equals to Q by T. I equals to Q by T. So if you multiply I into T, you should get the charge Q. Now here I is not constant, I is varying. I is varying with time. Then how can I calculate the total charge? To calculate the total charge, again, because it's a I versus T graph, the area under the graph, the area under this graph will give you the total charge. Now here also one more thing is that the graph starts from here, no value is given here. But this is 0, this is 200, so midpoint must be 100. And this is 200, this is 400, so the midpoint must be 300. So this is a very, again, another tricky question. So midpoint is 100 and 300, and now you can calculate the area. Now you can calculate the area. There are two shapes, one is this trapezium and one is this rectangle. Now area of a trapezium can be calculated directly. You don't need to divide it into a triangle, one rectangle over here, then another rectangle over here. That will complicate the problem. You can directly use the area of a trapezium formula. What is the area? So total charge is basically area of this trapezium plus area of this rectangle. So what is the area of a trapezium? Area of a trapezium is half into, okay, half into sum of the parallel sides. Sum of the parallel sides, that is 100. This one is 100. This one is 300. Sum of the parallel sides into the distance between the parallel sides. The curved size is completely ignored. So the sum of the parallel sides divided by, into the distance between the parallel sides. In this case, that is 10. In this case, this is 10. So we get half into 400 into 10. So you can cancel 5. You get 4 5s are 20. So 2000 microcoulomb. This is the first part. This is the charge Q1. What about the charge Q2? Q2 is very simple. This is the area of this rectangle. So area of this rectangle is length into breadth. Length is 300 and breadth is again another 10. So this is another 10, right? 20 minus 10. So it will be 3000 microcoulomb. Why microcoulomb? Because it is given in, sorry, not microcoulomb, millicoulomb. This is millicoulomb. Okay, because the current is given in milliampere, so it must be millicoulomb. Okay. Now what is the total charge? Total charge is very simple, Q1 plus Q2, which is equals to 5000 millicoulomb or 5 coulomb. Okay, milli means 10 to the power of minus 3, that means 3 zeros will be less, so 5 coulomb is the total charge. Now what is the total number of charge? Total number of charge, again, if you have listened to my lecture, there I have mentioned one shortcut method. 1 coulomb is equal to 6.25 into 10 to the power of 18. 6.65 into 10 to the power 18 for 1 coulomb charge. Here we have 5 coulombs, so multiply with 5. So we get 5 6 is 30, 1.25 into 10 to the power of 18. Now let's find the answer. So if you see that, correct answer is option A. So if you take one decimal out, you will get 3.125 into 10 to the power of 19. Okay, so 3.125 into 10 to the power of 19 is the answer. So last two questions. I am sorry, I am not taking any answer. I have to finish the lecture. The IV graph for a conductor at two different temperatures, 100 degrees and 400 degrees, are as shown in the figure. The temperature coefficient of resistance of the conductor is about per degree. So if you see that, here we have two graphs, and it is I versus voltage graph. Okay, I versus voltage graph. Okay, and they ask you the coefficient of resistance, not resistance, coefficient of temperature of resistance. Very interesting. And nothing is given, only the angle is given. This is 45, this is 30, and they ask you what is the temperature coefficient of resistance. Now first of all, you have to calculate the resistance. What is resistance? Resistance is V upon I. Resistance is V upon I. Now in this particular graph, V is plotted across x-axis, I is plotted across y-axis. So we can say that resistance can also be written as 1 upon R must be I by V. So basically I by V means delta Y by delta X. So this is along X, this is along Y. So what is delta Y by delta X? Delta Y by delta X is the slope of a straight line. Slope, this is delta Y, this is delta X. So slope of the line is delta Y by delta X. And what is slope? Slope is tan theta. Slope is tan theta. So 1 by R1 for this graph, say, is 30 degrees. So it will be tan 30. Tan 30 means it will be 1 by root 3. 1 by root 3. Right? What is, so R1 equals to root 3. R1 equals to root 3. Similarly, 1 by R2 equals to tan 45. 1 by R2 equals to tan 45. So R2 must be equals to 1 ohm. Okay, and root 3 is 1.7. We are taking 1.7 only. Okay, so R2 and R1 is calculated. Now the temperature difference is also given. Okay, temperature difference is given. Initially the temperature was 100, now it is increased to 400, and they ask you what is the temperature coefficient. So temperature coefficient is given, so you have to calculate the coefficient of resistance. Coefficient of resistance alpha is given by R1 into 100, sorry, So how to calculate the temperature coefficient? Temperature coefficient, you have to multiply the smaller resistance with higher temperature minus the higher resistance into lower temperature divided by the difference in temperature. Okay, so it will be 400 minus 170 divided by 300. Okay, so it will be am I doing it correct? No, sorry. Temperature coefficient, because temperature is given, you don't need to worry. It will be simply the difference in resistance divided by difference in temperature. You should apply this. This is an approximated method, but this should do well here. So R1 minus R2, that is 1.7 minus 1 divided by 300, that is 0.7 divided by 300. Okay, so it will be 7 by 3 into 10 to the power of minus 2, or 2 point something into 10 to the power of minus 3. 2 point something into 10 to the power of minus 3 here. Okay, 0.7. 0.7 we have removed the point, so it is 10 to the power of minus 3. So it will be 2 point something into 10 to the power of minus 3. Now if you see that none of the answer is matching, so closest answer is 3. So we will match with 3. Yes, Astha is you are correct. Sir, first PUC KCET are but easy, but then second PUC. Yes, Abhi, first PUC question most of them are easy. Some of them are tricky. You should realize that. For example, system of particles related questions can be tricky. Last year the system of particle based question was slightly tricky, and it is time taking as well. An electric bulb of 60 watt 120 volt is to be connected to a 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? So last answer A is correct, but if you solve it, your answer will not be exactly very close to the correct answer. Now, an electric bulb of 60 watt and 120 volt is to be connected to 220 volt source. What resistance should be connected in series with the bulb so that the bulb glows properly? So the bulb is rated 60 watt and 120 volt. Okay, but we are connecting this bulb with a battery of 220 volt. If we connect a resistance, say R, the bulb will consume this 120 volt required. Remaining 100 volt should be dropped across this resistance. Remaining 100 volt should be dropped across this resistance. Now, because the bulb has a fixed power rating, the current through the circuit should also be same as the power rating of the bulb. So power rating is given by Vodafone Idea. So current is given by power divided by voltage. Power is 60. Power is 60 watt and voltage is 120. So 60 divided by 120, that is 0.5 ampere. This is the current. The voltage drop across the resistance should be 100 volt. What is the voltage drop across the resistance? Very simple, I into R, that is 0.5 into R, and that drop should be equals to 100. Why 100? Because the out of 220 volt, only 120 volt is being used by the bulb. Remaining 220 minus 120, that is 100 volt, should be used by the resistance. So from here we say R equals to 200 ohm. R must be 200 ohm. So correct answer is option C. Clear? Yes. Asthag is correct. Aki, no, not 50. 0.5 is division. Okay. So 100 divided by 0.5. So that is 200. 100 divided by 0.5, not multiplication. Okay. So make sure you are solving this slightly correctly. Okay. Now, I hope all of you have learned something. I have also learned a lot of things along with you. And if you still have any doubts, obviously you can ask me in our next live session. The live session will continue for all subjects, okay, and we will try to complete it as early as possible so that you still get enough time for your PU2 preparations, right? I'll be back with a lecture tomorrow morning, so don't forget to check that out. And live will happen, I think next live will be happening next week, Monday. Till then, bye, see you soon, and hope you will